Hello alaikum. Miss Mona Shaheen. I'm gonna solve some questions on learning outcome 4 that concerns Newton's universal law of gravitation, free fall, and apparent weight. Question number 1. In the opposite figure, satellite B is 3 times than satellite A. Which satellite experiences a stronger gravitational attraction force with the Earth? Gravitational force formula equal G m1 m2 over r squared, that the gravitational force is in directly proportion with the mass. That satellite B has a greater mass than it has a stronger gravitational force. Okay, question number 2. The diagram shows two masses, mass m, and larger mass for m, with distance between them is d. Which one of the following has the greatest gravitational force? Okay, objects or the gravitational force between mass z and y will be the greatest, as it has a greater mass and a smaller distance. Okay, this is how it comes. Okay, diagram 3, question number C. Diagram blue represents two satellites A and B of equal masses. A and B are in circular orbits around a planet. If the magnitude of the gravitational force between satellite A and the planet was F, the gravitational force here is F, what will be the gravitational force at between B and the planet? Gravitational force is inversely proportional with the radius by increasing the distance between the two objects. By increasing the distance between objects 2 by a factor of 2, then it the gravitational force will decrease by 1 over 4. Okay, if r doubled, the gravitational force will be quartered. Question number 4. As an astronaut travels from the surface of the Earth to positions that 4 times than far away from the Earth, from the center of the Earth, the astronauts mass and weight. What about mass? Mass will remain the same. The gravitational force will increase will decrease as the distance increased. Distance increased by 4 times. Distance increased, that the gravitational field strength will decrease. Then the weight will decrease. Choices that this will be suitable, that the mass remains the same. Okay. Question number 5. Two planets X and Y have the same main density. Same main density doesn't mean that they have the same mass. Radius of planet X is half that of planet Y. Ratio of gravitational field strength over X over the gravitational field strength over Y. Okay, the masses are equal. The densities are equal. Densities are equal, that the density equal mass over volume of X equal mass over volume of Y. Constants 4 over 3 by constants will be cancelled. Then, and the radius of X is half that of Y. We replace or substitute for that in the relation for Rx by 1 over 2 of Ry. Okay, Rx Rx is bar cube. Then the ratio will become 1 over 8. 1 over 2 bar 3 will be 1 over 8 Ry cube. Ry will be cancelled with Ry, then the ratio becomes mx over my equal 1 over 8. Gravitational field strength formula equal Gy equal Gmy over Ry cube. Gx equal Gmx over Rx cube. with the same as we have done here. We replace Rx with 1 over 2 Ry, but it is of a power of 2. Then we'll put it in the denominator that it will be equal gx will be equal 4g mx over ry cube square. So gx over gy equal, the relation will become gy will be cancelled with gy and the j will be cancelled with g, that the relation becomes 4mx over my. Mx over my equal 1 over 8, that the gx over gy equal half. Ratio equal half. Question number 6. The gravitational force F2 between masses 2m and m will be equal. The gravitational force between the two masses here is F1. If the radius is decreased by a factor of 2, then the gravitational force F2 will be increased by a factor of 4. Okay? And if the mass is decreased by half, so the gravitational force will decreased also by 2. Okay, then the relation will become 2 times 4 gm bar 2 over ry. This is the relation of f1 that to f1. Okay, that the force will be doubled, mass halved. So if g decreased by a factor of 2 and radius halved, so mfg will be increased by a factor of 4. 4 over 2, that will be 2. Question number 7. The attraction force between two masses m1 and m2 distance r from each other, they can be calculated from the relations. If m1 replaced with another one of 2m, that the mass will be doubled, so the gravitational force will increase, but the g is constant, it will remain the same. Question number 8. Two objects attract each other gravitationally if the distance between its centers is quartered. What will happen to the gravitational force? Distance quartered, and it is inversely proportional with the gravitational force. The gravitational force is inversely proportional with the square of the distance. Distance quartered, that the gravitational force will increase by 16 times. Question number 9. Gravitational force between two masses is 100. What is the gravitational force if the distance is halved? Distance halved, so the gravitational force increased by a factor of 4. It was 100, so it will be 400. Question number 9. Number 10. When the elevator begins accelerates downward. Accelerating downward, that the apparent weight will decrease and the mass will remain the same, the weight will unchanged. Also, the weight is constant, the gravitational force will not change, so the weight will be the same and the mass unchanged, the apparent weight will decrease. Question number 11. A satellite launched from Earth into orbit. What happens to mass and weight of the satellite? Mass remains the same, but the gravitational force, the distance, increased, so the weight will decrease. Question number 12. The weight of 1 kilogram object at the surface of Mars is about 4 Newton. The radius of Mars is about half the radius of Earth. What will be the ratio between mass of Earth and mass of Mars and mass of Earth? Here is a mass and a force, or the weight will be 4 Newton. That the gravitational field strength on Mars will be 4. Okay, sorry. From the relation of the gravitational field strength equal gm over r square. For Earth, the gravitational field strength equal 10. Okay, and for Mars, the gravitational force strength equal 4. But the radius of Mars is half than that of radius of Earth. We put a relation between the two masses. Mass of Earth from here equal 10 times Re bar 2 uh, over G. And from here, by substituting for Rm from these relations, it will equal 1 over 4, 1 over 2 power 2, that it will be 1 over 4. 1 over 4, we put it in the numerators. So by cancelling 4 with 4, that ME will equal RE square over G. Okay, that's the ratio between M Mars and the mass of Mars and mass of Earth will be 1 over 10. It will be 0.01. Question number 13. Value of the gravitational field strength G is 10 on Earth, 1.5 on Moon. That the gravitational force on the Moon will decrease. Astronauts who has a mass of 90 kilogram on Earth. What will happen to mass and weight and weight on Earth and weight on Moon? Mass is the same, 9 kilograms, the same that on Earth. Weight equal mass times G. G on Earth equal 10. That 10 times 90 will be 900. And mass and weight on Moon will equal mass times the gravitational field strength on Moon, that will equal 135 newtons. Question number 14. The scale shown in the figures show that the mass will read the reading X on the spring scale. The system was at the equator. In Sweden, near the North Pole, the scale with the scale reading the weight. What will happen to the weight when it is moving to the North Pole? When moving to the North Pole, the radius will decrease, so the gravitational field strength will increase and the weight will increase. So the reading will be more than X. Okay. Question number 15. The gravitational field strength on Earth's surface is 2.63 times greater than the Mars surface. If the mass and weight on Earth M and W, what will be the mass and weight on Mars? Mass will remain the same. We had the relation between the gravitational field strength between Earth and Mars. So the gravitational field strength on Mars will equal 1 over 2.63 of gravitational field strength of Earth. So the weight of Mars will decrease by the same ratio, that it will be 0.38 the weight on Moon. Question number 16. An object is thrown straight. What is the net force on the object when it is at the highest point in the path? Object will falling in a free fall. That's the only force acting on it will be its weight. So the force acting on the object will equal to its weight. Question number 17. If the mass of an object in free fall is triple its accelerations, the mass tripled, but it is moving in, or it is falling in a free fall. Free fall that the object will move with the gravitational field current G. So if the mass doubled, the object will fall with the same acceleration G. It will stay the same. In the figure, what event will produce the greatest increase in the gravitational force between the two masses? The two masses are the same. By doubling the large mass, doubling the mass will increase the gravitational force by a factor of 2. Doubling the distance will decrease the gravitational force. This answer is not correct. Reducing the smaller mass by half, also that is incorrect. By reducing the distance between the masses by half, the decreasing the distance by half will increase the gravitational force by a factor of 4. But this is the greatest gravitational force. Question number 19. Your mass is 400 Newton. When the elevator just begins to slow and moving down, slow or move down while moving upward, the balance will read. It's moving upward, so the apparent weight will increase. Okay, apparent weight will increase, but here it's moving up but slowing down. Slowing down, so it becomes negative, that the weight will decrease. Your mass is 400 Newton when elevator begins to slow down while moving downward. Moving downward, that the apparent weight will decrease, but it is slowing down. Slowing down, that the acceleration will has a negative sign. Negative times negative, that the apparent weight will increase. Thank you.